Lesson 111, number 6. So this one, you can find this. This one just wants you to compute the permutation of 8 things taken 6 at a time, and the combination of 8 things taken 6 at a time. So I'm thinking maybe it's the notation is maybe confusing. If this looked foreign to you, what you would do is go over here and find lesson 111, and then it's number 6, so you would follow the 6 over. You'd find out it came from lesson 92, and then you would go back to lesson 92, and that's where the formulas are probably. I haven't actually gone there yet. Let's look. Lesson 92. 90, 84, 90, 88, 88, 89. 91, 92. So here are there some formulas? Here are the formulas. Right there. Okay. So if you ever see something and it looks like you don't know where it came from, or you don't know what they're asking, you can always use this reference sheet and look up the problem number and see where which lesson. So that says it came from lesson 92. I turned to lesson 92. I got my 2 formulas. Okay, so now that I got the formulas, I'm just going to compute them, because it just wants us to compute them. So the permutation of, now there's something interesting about the 2 formulas that I can't help but kind of talk about. Permutations are when order doesn't matter, or no, when order matters. Order matters. And combination is when order doesn't matter. Doesn't matter. Okay, so an instance where you would use a permutation would be if you're trying to make a combination for your, no, I shouldn't say combination because that's what that is. If you're trying to make a password for your, you're just trying to make up a password. 123 is a different password than 321. Okay, but so the order that you put the items in would matter. So you could have more passwords this way, because you could use 3 numbers, but you could put them 123 or 321 or 231 or 213. There's a lot of different ways you could order the numbers, and the order would matter. Every different way you order it would be a different password. But this is one where the order doesn't matter. So you use combinations when you're, usually I think of combinations as when you're picking teams. Like if I'm going to pick a group of 3 mathematicians, I'm going to pick Cameron and Chantel and Sarah to all be on my special math team. The order doesn't matter that I picked them. They're all 3 on the team. You know what I mean? It's not like I have a different team of mathematicians if I pick Chantel, Cameron, and Sarah. That's not a different group of mathematicians as Sarah, Chantel, and Cameron. You know what I mean? The order doesn't matter. So in some situations that you want to use combinations, some situations you want to use permutations. You notice that they're exactly the same formula, except for this one has an extra r factorial in the bottom of it. That makes it smaller. That makes the number actually come out smaller. Watch, when we do these, this number will be smaller because we're dividing by a bigger number. Because there's going to be, like, when the order matters, you get more outcomes than when the order doesn't matter, because 3, 2, 1 is different than 1, 2, 3. But in this one, if you have a 3 and a 2 and a 1, it doesn't matter what order you put them in. So that's just only counts as one outcome. So let's go ahead and plug the numbers in. Basically, I just wanted you to plug the numbers in. Permutation of 8 things taken 6 at a time. So we're going to put, so n is 8 and r is 6. So I'm going to put an 8 factorial. And then this is n minus r, so it's going to be 8 minus 6, which is 2 factorial. Now this one, I'm going to write the top as 8 times 7 times 6 times 5 times 4 times 3. I'm not going to write the times 2 times 1 because that'll cancel out with this bottom part. Okay, and then I can just find out what that big number is. 8 times 7 6 times 5 3. That's equal to 20,160 is what I got. We're 111 number 6. I'm checking it. Yes, that's right. Okay, and then over here, combination of 8 things taken 6 at a time. I'll have 8 factorial up here, and I'll have the 2 factorial, which came from n minus r. But then I have r factorial. What was r? It was 6. 6 factorial. Okay, so this one, so we're going to have more cancellations happening here. So we're going to go 8 times 7. I'm not going to write the 6, 5, 4, 3, 2, 1 because I'm going to let it cancel with this. Okay, and then down here I have my 2 times 1. And then the 2 can cancel with the 8, and I have, gosh, 28. Big difference, huh? So there's your 2 answers. There's your permutation answer, and there's your combination answer.